Chapter 3, Day 7. Graphing the inequality solutions. Learning target. I will be able to graph systems of inequality and identify points that satisfy each, both, and neither. So with the given inequalities, I'm going to graph the information based on what we learned in Chapter 2. So take a look at example number 1. First equation, y greater or equal than 3x minus 5. Second equation, y greater or equal than negative 2x plus 5. For first inequalities, I would like to graph the borderline. Since there's the equal sign, y greater or equal than, my borderline is going to be a solid line. 3x minus 5, 3x minus 5. So my y-intercept point is going to be negative 5. Slope 3 times x, so I know my slope is going to be 3 over 1. So right 1 unit, up 3. With these 2 points, I can graph my line. And it's going to be a solid line. Remember, it's going to be, the borderline is going to be the solid line. So my line does not look straight. So hopefully on your graph, you should make it straight. Which portion do I shade? Is it going to be above the line or below the line? So we practiced this in Chapter 2. I would like to use the testing point 0, 0. So if I plug it in 0, is this statement true or false? Is 0 greater or equal than 0 minus 5? So 0 minus 5 is negative 5. So 0 greater than negative 5 is true. So for this one, I am going to shade in the line that's above the line, the border line. So let me change to a different color. I'm going to shade. For first equation, I find I have to shade in the region that's above, including the 0, 0, the testing point. So that's my first one. The second one, I'm going to graph using the same method. So y greater or equal than negative 2x plus 5. Y-intercept point is going to be positive 5. Slope of negative 2. So I go right 1 down 2. Right 1 down 2. Right 1 down 2. And again, it should be a solid line because I see the equal sign. So for this one, I'm going to use a different color to shade. Do I shade above the line or do I shade below the line? I'm using the 0, 0 testing point again. Is 0 greater or equal than 0 plus 5? It's not. So I would have to shade the region that does not have the 0, 0 in it, which is above the line now. So I'm going to shade in the green color. So have you seen that which region is being shaded twice? Do you see that? I'm trying to emphasize which region was being shaded twice. So for this one, I'm going to shade it twice using a different color. Do you see that this region is being shaded twice? So that's going to be our solution point, solution set, solution regions. And that's the final answer. But remember, I asked you to test the points to make sure that the solution is indeed inside. So let's take a look at what would be the points, would be a good example for the points. So the solution for both, okay, I'm going to pick one that's like 2 and 5. 2 and 5. And you should definitely plug it in and check it. 2 and 5, do you see where I pick it? It's right here, 2 and 5. 2 and 5. Okay, I'm trying to make it darker. First one, but not second one. So the first one I have the color red. So for first, but not the second, I'm going to pick a point, say like 0, 0. We use the 0, 0 point. I like to use 0, 0. 0, 0 is very easy to test, to plug it in. Second one, but not the first one. So second one, but not the first one, I'm going to pick 5, 0. 5, 0. Do you see where I picked the number from? So for the region that I shaded, how about neither? Neither, I can pick a point, say like 2, negative 4. 2, -4, 2, -4. Do you see that where I pick it from? It's not being shaded at all. The region where it was not even shaded. And you can plug these numbers in and to check your answers. It should not satisfy the equations. Example number 2. Y less or equal than -2x plus 4. So let's go ahead and graph this first borderline. Again, I see the equal sign, so my line is going to be a solid one. -2x plus 4, so my y-intercept point is going to be positive 4 with a slope of -2, so right 1, down 2, right 1, down 2. I'm going to graph the line as a solid line, right 1, down 2. Is it going to be above the line or below the line? So let's go ahead and plug it in 0. So do you see that 0, 0 at this point is below the line? So if we satisfy the condition, then we're going to shade in the region below the line. So I plug it in 0, 0 for x and y. So 0 plus 4, that's 4. 4 is indeed greater or equal than 0. I'm going to use the same color I did for the first example. So for first line, I'm going to use red one. And I'm going to shade in the first region, the region that contains the 0, 0 testing point I used. How about the second one? So there's no equal sign. So make sure for your second one, it has to be a dashed line. So y less than x minus 3. Our y-intercept point is going to be -3, and it has a slope of 1. So remember, it has to be a dashed line. So let me graph the line as in dashed line. Again, I'm drawing it with my hand, so my line may not look very straight. You should use a straight edge to help you draw the border line, and it has to be dashed because there was no equal sign there. Which region do I shade? So let me change to the color. I can test the point first. 0 less than 0 minus 3. Is this statement true or false? Is 0 less than -3? No, it's not. So I should shade the region above. I should shade the line that does not, I should shade the region that does not have the 0, 0 in it. I should shade the region that does not have 0, 0 in it. Do you see that? So 0, 0 is not. It is above the line, so I'm shading below the line. So which region was being shaded twice? Which region was being shaded twice? Have you seen that? So this is the region that's being shaded twice. So I'm going to darken it with the third color, okay? And then what would be the points that, so the last section, what would be the points that satisfy both of them? So again, the region being shaded twice, which I mark it as in color blue. So pick a point from there. This time I'm going to pick when x equal to 2. How about y equal to -3? So do you see that this? X equal to 2, y is -3. X equal to 2, y is -3. It's inside the blue region that I shaded twice. First one, but not the second one. So the first one was I used the color red, I'm sorry. The first one I used color red, but not in the second. So obviously, the 0, 0 point, the testing point that I use, belongs to the first one, but not the second one. Next, we have second, but not the first. So the second, I use the color green. So which one would be a good candidate for this point? How about let's choose 5, 0. 5, 0. You can choose any point as long as it falls in that region. So I'm just going to pick one point, 5, 0. Neither. So is there a region that's not being shaded at all? So do you see this corner, this side? It's not being shaded at all. This region is not being shaded at all. So I can pick a point. How about, let's say 3, 4. 3, 4. It belongs to this region, not shaded at all. 3, 4. The conclusion of today's lesson is to emphasize that linear inequalities are the region where being shaded twice. Linear inequalities solutions are being shaded twice. So you should pick the points from this region and plug it back into the equation to verify your answers.